Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video, and by the end of it you should be able to understand and apply the remainder theorem. So the remainder theorem is useful when we are dividing polynomials. Now we saw in a previous video, when you add, subtract or multiply together two polynomials, you get another polynomial. So those operations are really easy. The same isn't always true, however, when you divide one polynomial by another, and that's where we need the remainder theorem. But we need to first look at what do we mean when we're dividing one polynomial by another. So to illustrate this, let's look at x squared plus 5x plus 6 divided by x plus 1. This is a polynomial, this is a polynomial, and this fraction line means divide. So remember, division just undoes multiplication. What we're trying to do is we're trying to find a polynomial that we can multiply by x plus 1 to get x squared plus 5x plus 6. That's what polynomial division is all about. And so, of course, this is analogous to division of integers. If I say 67 divided by 4, I'm saying, what can I times by 4 to get 67? Now, you probably note, I can't multiply 4 by an integer to get 67. 4 doesn't go easily into 67. But what I can do is I can multiply it by something that gets me close. So 4 times 16 is actually 64, which is close to 67. And then I would need to add 3, and we call this number here the remainder. And so this is also true for polynomials. It turns out I can't find a polynomial that I can multiply by x plus 1 to get this. But I can find one that will get me close. And what I mean by close is I can find a polynomial that I can put in here that will get me x squared plus 5x. It will get me the first two terms right, but the constant term may be different. So if I were to say put in here x plus 4, and expand that, I actually get x squared plus 5x plus 4. So you can see this is very close to this one here. The only difference is the constant term. So I can multiply this by this. If I add 2, then I'll be done. X plus 1 times x plus 4. If I expand that and then add 2, I get this here. So once again, we call this number here 2 the remainder. So it turns out there was a much easier way to find this remainder than figuring out what I need to multiply by x plus 1. And that is using the remainder theorem. So this is what the remainder theorem is. When you take a polynomial f of x and divide it by a linear factor, we're only looking at linear factors, x minus a number, then the remainder is f evaluated at this value. Okay, that probably doesn't make a lot of sense. So let's look at our example again up here. So if we let fx be our polynomial x squared plus 5x plus 6, we're dividing it by x plus 1. X plus 1 we can write as x minus 1. So this is our a value here. What the remainder theorem says is the remainder, when I divide this by this, is just this polynomial evaluated at a, in other words at minus 1. So if I substitute in x for minus 1, remember substituting a negative, you must use brackets, and I will get this. And that answer is just 2. Notice this is the same as I got up here. So the remainder when I divide this by this is 2, because when I substituted this value here for x, I got 2. That's all there is to the remainder theorem. Thanks so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.